Hi, my name is Shogotor Hassani. This is the demo video for our project Ransomware Attack Simulation and Mitigation in a Virtual Environment. Our team members are Shogotor Hassani, that's me, and Sai Chandra Bandrapalli. So in this video, I'll show a short overview of our ransomware simulation does, how we safely simulate a ransomware attack inside a virtual machine, and how our monitoring, detection, and mitigation system works, and a live demo of files being encrypted and recovered. So our architecture is four main parts. First one is ransomware simulation. This is the script that encrypt file using RSA encryption. And second part is infection simulation. And third one is monitoring and detection. And fourth one is mitigation. So for this, in this seed Ubuntu virtual machine, I have a project directory called ransomware, this one. Okay, and inside this folder we have a personal ss435. This is a victim data folder. It contains several subfolder like secret 1, secret 2, and secret 3. And encrypted sim, we have also a one encrypted sim. After an attack, this folder will store the encrypted version of the files plus metadata, and also I have decrypted sim. When we successfully decrypt, the recover files are written here. A keys folder, this one keys folder where we store the RSA key pair, this one. And our main Python script is this one, ransomware sim.py, and then monitoring.py, and this one detection.py, and mitigation.py. So next I will briefly explain in RSA encryption we use and then run. So here RSA, our project uses RSA, which is an asymmetric encryption algorithm. Asymmetric means we use two different keys: a public key that is used to encrypt data and can be shared, and a private key that is used to decrypt data and must always be kept secret. When the ransomware runs, it generates an RSA key pair and stores them in a case folder as a PM files. The public key used to encrypt the victim file. Since RSA cannot encrypt very large data in one shot, split each file into small chunks in our program. Also, write the encrypted chunks to .enc file in encrypted folder. So to recover the data, we need two things: the RSA private key, a token which in our simulation plays in the role of secret decryption. So here I will here in the terminal I am inside the ransomware directory. To launch the attack, I run python 3 ransomware, python 3 ransomware sim.py encrypt. So the script starts scanning the personal SS434 directory for each target file. It performs the RSA-based chunk encryption and print message like something this one is. So once the files are encrypted, uh, the program displays a ransom like this one, ransom attack. Your files have been encrypted in a major ransomware attack. In our example, these notes tell uh, the victim to send $3,000 to $3,000, and then email to screenshot of payment. It also instruct the victim to run. So here you can see the mm, lab 1 manual from encrypted sim secret folder open in the Blaze hexa editor. So on the file we see random looking hexabyte. On the right, the SCL panel, there are only graph character. So now now I'll show you decryption phase recovering files. So I now run python 3 ransom ransomware sim dot py dot decrypt. So I need to token. I will check the token file. This one the token file. Copy 1 2 3 4 5. The program first prompts me to enter the decryption token and then asks for the RSA private key passphrase. In the real attack, the victim would only get this information if they paid the ransom. In our simulation, we already know the token and the passphrase, so I entered them here. Once the correct values are provided, the script begins decrypting the file. So, file. Now I will demonstrate our monitoring component. So this terminal I run python python 3 monitoring.py. So this script prints already monitoring target. This means the monitoring is actively watching the personal ss433 folder. So I this one. So now I will modify this folder. This file, if I modify this, modify done. Now you can see it's already modified. You can see this already modify alert this. So modify done. So now we use our detection engine to analyze them and look for ransomware like behavior. So now I will run python 3 detection.py detection.py. Here you can see the modify with no candidate process. So each violation included time spent, the file path, the action, and a list of candidate process. In this example, the candidate list is empty, meaning no trusted process has been associated with this change. In real deployment, this would be considered highly suspicious and would trigger a response. So the detection engine successfully reads events from monitor.db, applies rules on time and behavior, raise alert when the pattern resembles a ransomware attack. So now finally I will demonstrate our mitigation module. Now I'll run python 3 mitigation mitigation mitigation.py. So the script already prints mitigation component start and then process each violation one by one, and it also logs warning. So if I mitigation component finished. Now my I will check my email folder. So which email? Already I have selected one email for this project, and I will show it here. So if I check this folder file, and you can see can see the mitigation. If I mitigation, I'll show the email address. Email address. Sorry, I'll show the email address. I'll show the email address. This one, the raha.shogoto14@gmail.com. This is my email address. And now if I open my Gmail address, this one, raha.shogoto@gmail.com. Shogoto, I can see all of these messages with the subject urgent security alert unknown detection. When I open one of these email, a security alert has been triggered by our automated monitoring system that it showed action detected, file or both, if it is. So this is a complete the demonstration of our mitigation and notification pipeline. So we implement a controlled ransomware simulation using RSA encryption and ran it safely inside a virtual machine. This ransomware encrypts files in the personal SS443, that is my UID folder, and also requires a requires a token and private key for decryption. We prove that the files are really encrypted by viewing ciphertext in a hex editor. This one, hex editor, and we successfully restored them with our decryption script. We built a monitoring module that logs file system event, and our detection engine analyzes these events and raise alert when it sees suspicious patterns like multiple repeat file modification. Yeah, this one. See this one, and finally this one, last one is mitigation part. Mitigation component process violation and sends automatic mails. Look, this sends automatic mails about these alerts to administrator with details and recommended actions. So in the future, thank you for watching this demonstration of our project ransomware attack simulation and mitigation in a virtual environment. My name is Shogotora Sani, and this is concludes the demo.